Hi, today's lesson's on inverse variation of the reciprocal function. First thing we're going to do is learn how to identify inverse variations using a table of data, basically. So the way it works, what makes things vary inversely as one thing increases, the other one decreases consistently. So the way we check that is we just got to multiply all the values. So 12 times 1 is 12. 6 times 2 is 12. 4 times 3, 12. 3 times 4, 12. 2 times 6, 12. 1 times 12, 12. Since those are all 12, this is an inverse variation. Moreover, with a constant k of 12. So to see if this one's an inverse variation, we do the same exact thing. 20 times 1 is 20. 17 times 2 is 34. Since those are not the same, this is not an inverse variation at all. And you can see it follows that as it increases, it decreases, but it just doesn't work. Go ahead and see if this table represents a inverse variation. So by definition, inverse variation is y equals some constant divided by x. And the way we say this is x varies inversely as y. So if you notice, as x gets really, really big, y gets really, really small. And if x gets really, really small, then y gets really, really big. They go in opposite directions. So the thing is, if x goes to infinity, if it goes on forever, basically y is going to get so small because x is getting so big, it's pretty much zero. And that is one of the key concepts of future math classes called limits. So how do we use inverse variation? Well, we know a couple things. We know the formula is y equals k over x. And if you can rewrite this, you rewrite it as k equals x times y. So first we got to do is find k, and then we can find this formula. So it says in inverse variation, x equals 10 when, that's the key word, y equals 3. So that's our x and y we're going to use here. So k equals 10 times 3, which is 30. So that gives us an equation of 30 over x. Now we can use this to find values. Then find the value of y when x is negative 6. So 30 over negative 6 is negative 5. And we're done. Go ahead and try this problem. So how's this used in real life? Actually, Pythagoras is the one who figured this out. Is on a guitar, any stringed instrument really, the length of the string varies inversely with its frequency. In other words, the shorter the string is made, the higher pitch there is. And so they noticed that the 26-inch E string on a guitar goes at 329.63 cycles per second. So what's the frequency going to be when it's 13 inches? It's basically going to be half as much as in distance, so what's going to happen there? So the way we do this is we know we multiply these together to find k. So 26 times 329, 329.63. And now all we got to do is divide that by 13. And so we get our answer is 659.26. And that'd be its frequencies in cycles per second, which is measured by hertz, by the way. All right, how do we graph a reciprocal function? So if you notice, the inverse function is a reciprocal function. What makes it that is the x is on the bottom. So I'm going to make an xy table for this so you guys can see the patterns that are made. So x and y. So just to show it, I'm going to go start with 4. I'm going to do 2, 1, 1/2, 1/4, 0, negative 1/4, negative 1/2, 1, or negative 1, excuse me, negative 2, and negative 4. If we notice these, reciprocal just means do the reciprocal, flip it. So this would be 4 over 1, so it's just going to be 1 over 4. This will be 1 over 2, 1. Now the reciprocal of 1/2 is just 2. This will be 4. We'll skip 0 for now because it's special. And this would be -4, -2, -1, -1/2, and -1/4. So if we go ahead and put this on the graph, so 4 over here would be 1/4, which would be right here. We have 2, which would be 1/2, which would be right here. We have 1 would be 1. We have 1/2, which is this line, would be 2. And this would be 4. So if you notice, our curve kind of goes like this. And now for this side, we're skipping 0 for now. -1/4 would be right here. B2, B1, B2, B1. So we get this curve like this. Now if you notice, can we divide by 0? 1 over 0 is undefined. So what we call that is an asymptote. Now what an asymptote is, it's basically a fence that the graph usually can't pass. So we actually have two of them. We have that one, and we have the one that goes horizontal. So we call these the horizontal asymptote and the vertical asymptote. And this is the parent function of all reciprocal functions. So we base everything off this special point, which is called, I call it the center, which is where the asymptotes go through. And the reason it starts low and ends high is because this is a positive function. So if it was negative, you'd start high and then end low. So for example, this one, what if it's shifted? Okay. So the way we do this is just like we always do with the vertex. So I'm going to call it the center. And the opposite of -3 would be +3. And the 2 on the outside would just be 2. So we're going to go ahead and graph that point. So that'd be 3 and 2, which is right here. Now you draw your asymptotes, your vertical, your horizontal. And now we're going to see if it's positive or negative. Since 1 is positive, we know it's going to start low and end high. So we know this kind of looks like this. Kind of that kind of shape. It doesn't have to be perfect, it's just a sketch. Now the domain and range, it can be all numbers for your x's except for 3. It can be all numbers for y except for 2. So the way we write that is we just say domain is all, but x cannot equal 3. And the range is all, but y cannot equal 2. And that's basically how you do it. Go ahead and try this problem. Try this problem.